Before we go too much further into our discovery of vectors and how they're used, it's important that we learn how to write a vector correctly, and we'll do that by just looking at this little diagram here. So we've got our x and y, our Cartesian plane, and we'll put a vector here starting at this point and going to that point there. So we'll call the starting point A and the finish B. We'll indicate direction by the arrow, so it has a magnitude. Magnitude is by the length from A to B, and a direction is indicated by the arrow. Now, how do we represent that by writing it without doing the diagram? Well, it's certainly A to B, so the direction's important. That's implying the direction going from A to B, and the vector is indicated by just putting a squiggle underneath. If we look at the vector starting at B and going to A, which means the arrow would be reversed, it has got exactly the same magnitude, except the direction is completely the opposite. So we can say that the vector AB is exactly negative vector BA. The magnitude of the vector is indicated by simply putting straight lines on either end, so that would indicate the magnitude only, not the direction. So that's the way we write magnitude. It's just a straight line. Sometimes you see it as absolute value of, there are the modulus of, the length of AB. All those different words can be used to just indicate the magnitude of AB, but that is the way in which it is written. Not only do we have using the endpoints, but if we had another vector over here, C, we can use lowercase. So we've just got vector C. It's got a starting point and an end point. That's not given any meaning in vector C. You don't know which way it's going. So vector C is the way to write it. But obviously there would have to be something else written there to indicate which direction it is going. And once again, magnitude of vector C, we would write like that. The vectors can be equal. Now, all vectors don't have to start at the same point. So if we had vector C there in that quadrant and another vector that had exactly the same length as C and it was, say, parallel to it, we could also say that that is vector C. We could have vector C here as well. So equal vectors don't have to always start at the same spot, as long as they have the same magnitude and they are all parallel, if you like. So all those vectors are exactly the same, and we just write them as vector C. So we've talked about equal vectors. All these vectors here are C. We could have vector down here, starting here. Try and draw it parallel to there, to AB. So we'll call that capital C and D, and going like that. And as long as that length from there to there is exactly the same, we could say that vector AB is equal to vector CD. So they'd have to be parallel, and the lengths would have to be exactly the same. So we'd say that AB is equal to CD. Not to confuse that capital C there with this lowercase c up here. All right, so that's equal vectors. How to write a vector. Don't forget to put the little squiggle underneath, and that's how we write vectors.